Hello everyone, it's my pleasure to meet you all. My name is M. Swapna. So today I am going to start the first lecture on Mathematical Foundations and Computer Science subject. So here we are going to see discrete mathematics. So the first concept which is included in MFCS is what do you mean by discrete mathematics. So here this mathematics concept can be divided into two types. The first one is discrete mathematics and second one is continuous mathematics. So that we will see in the next coming further sessions. Before going for the types of mathematics, here first we need to know why we are using discrete mathematics and what are the applications in our real life where we are using this discrete mathematics, that we will see first, and afterwards we are going to enter into the subject, that is the types of mathematics and what are the different types of symbols that we can use in the discrete mathematics, that we will see. So here discrete mathematics, mathematics is branch of mathematics involving discrete elements that uses algebra and arithmetic. So algebra and arithmetic is nothing but we are going to use some different types of operations, whether it may be addition, subtraction, multiplication, negation and or. So all these will come under different types of arithmetic operations. So we are going to use all these operations between different types of symbols in discrete mathematics. The term itself, that is discrete mathematics, itself indicates mathematical foundations for computer science, and one more name for this mathematical foundations for computer science is discrete mathematic structures, or we are going to call discrete mathematics or MFCS. So in different types of universities we are going to call different terminologies. So in our curriculum we are going to prefer mathematical foundations and computer science. So already in the previous lecture I have introduced what are the concepts that we are going to introduce in each and every unit. Already we discussed in the concept of width and wheel. Now we are going to see the first unit concepts, that is branches of discrete mathematics, that is set theory, logic, combinations, graph theory, number theory, probability theory, algebraic structures. So already these concepts can be included in the diagrammatic representation of width and wheel that we can introduce in each and every unit. In our first unit, mainly we can focus on set theory and logic that we are going to discuss in our first unit. So here what it contains, prerequisite is to learn discrete mathematics, that is basic algebra, logic, set theory, functions and relations, proof techniques. Again it can be related to each and every unit. These are the prerequisites. So here these are the different applications of discrete mathematics in our real life, where we are going to use in our engineering terminology, how we are going to use this discrete mathematics. In the first we are going to use designing efficient algorithms. So what do you mean by this? Designing efficient algorithms. If we consider data structure subject, how we are going to use discrete mathematics? So if you consider binary search, linear search, whatever it may be. So here we are going to compute some time complexity. So this can be computed with the help of mathematics concept. So that mathematics concepts will come under discrete mathematics only. So in such cases, we are going to use the concept of discrete mathematics in data structures. That is the first application of discrete mathematics. And second one is set theory and relational algebra. And third application is relational database management system. So where we are going to use this relational database management system? If you are going to write some queries between tables, that may be either customer table or employee table, whatever it may be. So between the tables, how we are going to perform the operations, that is whether is there any common keys we are having or any independent keys we are having. So these will come under different types of union, intersect, except like that we are going to perform different types of operations between the tables. So that concept will come under relational database management system. This is the third application. And next, fourth application is graph theory and computer graphics. How we are going to use this discrete mathematics in graph theory? How this graph theory contains different types of vertices, edges, paths, connectivity. So we are going to compute, if you consider any graph, again we are going to discuss different types of graphs. So if you consider any graph, how many number of vertices we are having, how many number of edges that we are having, how we are going to color the graph, everything can be related to graph theory. That we are going to discuss in graph theory. And next, how we are going to use computer graphics. So graphics is nothing but simply the term itself. We are going to provide some animation. How we are going to provide that animation? By using image processing techniques. If you consider any image, so within that boundary, we are going to find some pixels. So between that each and every object, what is the distance between near to particular each and every object or surrounding objects? How much distance that we are having between that objects, that we are going to calculate with the help of discrete mathematics. So this image processing is also one of the application of discrete mathematics. So these are the various applications of discrete mathematics. Next, we are going to see the definition of discrete mathematics. How we are going to define. So simply, in simple terms, how we are going to define this discrete mathematics is, it is a branch of mathematics that contains only distinct values. Distinct values. So what do you mean by that distinct values? And here I have given one more concept. The term discrete refers to the, it can be counted, whole numbers, unlike continuous structures can take only any value within the range. So first we will see what do you mean by this discrete and continuous. If you consider a graph like this, whereas if we can go for the discrete mathematics, we are going to indicate the graph as in terms of objects and variables. If we can go for the continuous mathematics, here also we are going to represent objects and variables, but here we are going to represent the graph indication as line. Continuous. So simply by seeing this graph, how we are going to define? So here we are going to count how many number of objects. Whereas if we can go for continuous mathematics, we are not going to count how many number of objects that we are having. So that is the major difference between discrete mathematics and continuous mathematics. So the first difference between this discrete mathematics, continuous mathematics is nothing but we are going to define some objects and variables in both categories. Then where we are going to find the difference? In discrete mathematics, we are going to count the number of objects. Whereas in continuous mathematics, we are not going to count. That is the first difference. And one more difference between these two is nothing but here this graph is finite graph. Whereas in continuous mathematics, this graph is continuous graph. Continuous. We are not going to find any gap. Here we are going to find the gap. That is one more difference. Okay. So how we are going to give the examples for discrete mathematics and continuous mathematics? If you consider any textbook, whatever it may be. So if you consider the textbook, we are going to give the count for how many number of pages that we are having. Simply we are going to give some 20, 30, 40. But we are not going to give the count as 20.5, 30.5 like that. So simply we are going to represent in terms of whole numbers. So that category will come under discrete mathematics. Then what is the example will come under for continuous mathematics? If you consider the person age. Okay. So how we are going to calculate the age? So directly we are going to say some 30 or 40. So how we are going to calculate that 40? Okay. So we are going to consider years, months, days, weeks, hours, minutes, seconds. By considering all these factors, we are going to calculate one person age. It is not unique. So this type of example will come under continuous mathematics. It is a continuous process. Whereas discrete mathematics is nothing but simply we are going to find the count, how many number of pages we are having, how many number of books that we are having in a cupboard. So like that we are going to find the real numbers will come under continuous mathematics, whole numbers will come under discrete mathematics. So these are the classification in discrete mathematics. And next, importance of discrete mathematics. So already we had seen what are the applications where we are using in different types of programmings. So already we had seen in data structures, relational database management systems, and next computer graphics, and next image processing, everything. In everywhere we are going to use this discrete mathematics. And here the first concept in our syllabus is mathematical statement. Mathematical statement. How we are going to define this mathematical statement, and the another name for this mathematical statement is simply propositional logic or statement. So these are the different terminologies for mathematical statement. So how we are going to define the statement? So a statement is a declarative sentence that can be either true or false. It cannot be both true and false simultaneously. Okay. If you consider any statement, for that statement, we are going to find the output, whether it may be true or false. But at a time, we are not going to find the result as 2 at a time. So such type of statements is nothing but mathematical statement. So these mathematical statements can be appeared in 2 forms. The first form is atomic statement and the second form is molecular statement. Then what is the difference between atomic statement and molecular statement? So in a simple terminology, every sentence will come under atomic statement without involving more than one statement. That is atomic statement. It is a dog. And here I have given telephone numbers in the USA have 10 digits. The moon is made of cheese. It is a single sentence. We are not involving more than one sentence. Such type of statements will come under atomic statements. So how we are going to give the definition for atomic statements? We can't divide further. It is a single statement. It is a simple statement. And for that statement, again we are going to find whether it may be true or false. That we will see later. And next, here I have given one more term, non-statements or non-mathematical statements or non-propositions. What do you mean by non-propositions? If particular sentence represents some questionnaires, we are not going to find the value, either it may be true or false. And interrogation questions, some ordering the questions, that is, go to your room. Just we are ordering some person, just you can go to your room. So some interrogative questions. So such type of statements will come under non-propositional statements or non-statements. So this is the difference between atomic statements and non-propositional statement. See, in our regular life, every statement will come under atomic statements. And one more, I have given example, variable expression. So if we consider 3 plus x equals to 123 plus x equals to 12. So I have given the expression as some left hand side part, right hand side part. But here we are not assigning any specific value for x. If I consider x equals to 2, the result will be different. If I consider x equals to 5, the result will be different. But we are not going to find the value of x. Such type of statements will come under non-propositional statements. And next, what is the next second category? Molecular statements. So the reverse of atomic statements is molecular statements. So what I said in previously, atomic statement is nothing but each and every single statement. So here we are going to include more than one statement. More than one statement is nothing but molecular statements. By combining two simple statements, That will come under molecular statements. So that is the difference between atomic statements and molecular statements. And next, so these are the atomic and molecular is different forms of the mathematics. Next, again we are having types of mathematical statements. What are the different types that we are having in mathematical statements? So mathematical statements are used in logical reasoning in discrete mathematics. So what are the main types? The first one is propositions. How we are going to define? Already previously what I said, it is a declarative sentence. What we are going to produce? Either true or false, but not both. So this is the actual definition of proposition. Or one more name for this proposition is statement. Here I have given the example as the sky is blue. This can be true or false depending upon the time of the day and weather conditions. So upon climate condition, the sky color can be changed. So according to that condition, we are going to produce the result as either true or false. So this type of statements will come under propositions. And next, if we consider 2 plus 2 equals to 4, always it will be true. So if we consider 2 plus 2 equals to 6, so then what is the resultant? False. So at last what we are producing? Some result. So we are going to produce the result. The proposition result is truth value. Truth value means it's not true. Either we are going to produce truth value. Either we are going to produce true or false. If it is true, we are going to indicate 1. If it is false, we are going to indicate 0. So these are the symbolic representations for true and false. So this is proposition, the first type of mathematical statement. And second category is predicate. Predicate is nothing but we are going to assign some value to the variable. Suppose if I represented x equals to 3. X equals to 3. Then we are going to give the representation as x is greater than 5. This is statement or non-propositional statement. First we are going to find. So it is statement because it contains only single statement. It is not mixed with more than one statement. So here p of x can be represented as x is greater than 5. So this becomes a proposition when we are going to assign some value to the x. So here what I have given, x can be treated as 7. X can be treated as 3. So p of 7. P of 7 is nothing but in place of x we should replace this x with 7. 7 is greater than 5. Condition is true or false? So 7 is greater than 5 means always it is true. And one more statement, p of 3 is false. In the place of x, if I represented 3, 3 is greater than 5. Condition is true or false? It is false. So at last we are producing some result with the help of assigning some value to particular variable. That will come under predicate. And next, third category, quantified statements. So here how we are going to define these quantified statements? We are going to use some quantifiers. Quantifiers. How many types of quantifiers that we are having? Universal quantifier and existential quantifier. And this is the representation for universal quantifier and this is the representation for existential quantifier. So the meaning representation for this symbol is for all. And here there exist. And this is one example for that for all and there exist. And next if we can go for logical operations. So again logical operation is simply we are having one and only one operation, that is negation. So we are going to, the meaning of this symbol is not. We are going to see these types of representations in depth in the coming concept, that is connectives. So here just I am giving the symbolic representation for each and every statement. And next representation is conjunction. This can be represented with the term and the symbol for representation, this and is nothing but here. So how we are going to use this conjunction? And. So when we are going to use this and word, if you are having more than one word, so automatically more than one word means it will come under molecular statements. So always we are going to apply this conjunction for molecular statements, not atomic statements. We are not going to consider single statements. We are going to consider more than one statement. Between that statement, what is the word that we are going to use? And that we are going to apply. So, and next operation is disjunction. So, the word for this disjunction is or, and this is the representation for disjunction symbol. And again we are going to consider more than one statement. Between that two statements, we are going to apply disjunction operation. And next, implication. So this is the symbolic representation, and the meaning for this symbol is if then. And next, biconditional. The meaning for this biconditional is if and only if. The symbolic representation for this biconditional is two directions. These are the terms. What is the corresponding meaning? What is the symbolic representation? In depth we are going to see what is the meaning of these symbols. That we will see in the concept of connectives. So here the next, logical connectives. So already previously we had seen the different types of mathematical statements. Already we had seen this and, or, if then, if and only if, and not. Next we will see how we are going to apply all these symbols in our terminology. So truth tables. So what do you mean by truth table? Truth table is nothing but it is all possible combinations of truth values for compound propositions. Compound propositions is nothing but moleculars only. We are going to include more than one statement. So they are used for understanding and analyzing logical expressions. So if you consider conjunction, so this is the corresponding truth table for conjunction. So this is symbolic representation, and this is corresponding truth table for conjunction. So then how we are going to find, how we are going to compute this conjunction operation? So here I highlighted this specific red color. If first statement is true and second statement is also true, then in that case resultant is true. So this is the actual definition of conjunction. If both statements are true, then the resultant is true. In remaining all cases, the resultant is false. So this is the definition of conjunction, symbolic representation, and what is the symbol for representing conjunction, and the corresponding truth table. In the next coming section, just we are going to see some problems depending upon this, all these logical connectives. So this is the truth table for conjunction. And next is disjunction. So whereas in conjunction, how we are going to find the truth table? If both cases are true, then we are going to produce the result as true. The reverse of conjunction is disjunction. So what is the reverse? If both cases are false, then the result is false. And in remaining all cases, we are going to represent the result as true. So this is disjunction. This is the symbolic representation. This is the corresponding truth table. And next, implication. So what is the meaning of this representation? If then. If something happens, then what we are going to find? That is the meaning of implication. So the truth table for this implication is how we are going to find if the first statement is true, the second statement is false. First statement is true, second statement is false. In that case, the resultant is always false. In remaining all cases, true. So this is the corresponding truth table for implication. And next, biconditional, where we are going to find the difference. Both statements are true or both statements are false. In that case, what is the resultant? True only. In remaining cases, the resultant is false. So this is biconditional. And next, one more, negation. The meaning of this negation is not. So what is the actual condition that we are having? We have to write the reverse, not. So if the statement is true, then negation of that particular statement is false. If the statement is false, the result of that particular statement is true. So this is a corresponding truth table, symbolic representation for negation. So all this will come under the basic concepts of statements, notations and logical connectives. Thank you one and all.
Like, share, comment and subscribe VNR Digital Learning Resource YouTube channel.